Good afternoon, ladies and gentlemen. Good morning for those for who it is the morning for the time being. My name is Jacques Pouzet. I'm working at Eurocontrol, heading the communication and frequency activities. I'm pleased to moderate the first seminar on SATCOM for aviation. You may remember we organized previously some similar seminar on different communication technologies such as LDAX. This one is the first of a series of seminars that will be dedicated to the satellite communications. So these webinars are organized in close conjunction with several other organizations, namely the SGU, the European Space Agency, the SESAR Deployment Manager, and today we are going to have participants as well from ICAO, IATA, and FAA that I thank for being with us. So these webinars are dedicated to the digitalization of air traffic control that is requiring more air-ground mobile communications. Hence, this need was identified about 10 years ago already by ICAO. We will see later some speakers that are reminding us what has been decided at that time. The technology have evolved, and in particularly the mobile communication technology in terrestrial, but also on the SATCOM. And in Europe, you may know that we are currently running a business case to propose a decision to our decider that are the network director of technology, so-called NDTech. And this series of action is joined under the action that we have had from the joint CNS stakeholder platform. So today we are going to speak about the new SATCOM services with an overview of the different SATCOM solutions that we have today for aviation, for both ATC and AOC, but also potentially for passenger communication. So the objective is to increase the awareness on the SATCOM technology. So we have planned a series of 3 to 4 webinars. Today we have planned three seminars. The first one, this one today, dedicated to the SATCOM perspective, to see where we are on the SATCOM today. The second one that will be dedicated on the IRIS, which is a dedicated services developed by the European Space Agency in close conjunction with industry. And then we are going to have a third one on the SATCOM maturity and deployment. And you can see the date for the different seminars. The second one is planned on the 16th of February, the third one on the 14th of March, and others will continue for other satellite technologies. So today we have eminent panel members. So we have first Martina Angelone from the European Space Agency that is going to make a part of satellite technology. Von Mayola from ICAO, that you know already, was participating at our first seminar on LDAX. We are going to have Nopodol Pringvanich from IATA to provide the stakeholder view and maybe the airline views. From FAA, we have Ravi Jain, who is representing Brent Phillips. Thanks, Ravi, for joining us. SGU, we have Ruben Flor, and the SDM, Davide Corinaldesi. Personally, my name is Jacques Pouzet. I will be together with Philippe Sacré, basically to be the moderator of these webinars. So regarding the agenda, we are going to have several presentations that will be followed by a Q&A sessions. So we have decided to go first to all the presentation. We have for about 1 hour presentation. Then later on, we are going to have some Q&A sessions and we will try to answer to all the questions, not all, but at least the main questions that will be raised on the chat. May I ask you to use the Q&A sessions that you have on the Zoom applications to raise a question that will be distributed through the panel member. And that's basically it from my side. So I will stop sharing my side and pass the floor to my colleague Nopodol, who will start as stated by the, let's say, the view of the stakeholders. And we will start with Nopodol. So Nopodol is the global head of Air Traffic Management and Aviation Radio Spectrum for International Air Transport Association, IATA. He is responsible for developing IATA global policy strategy for airlines position relating to CNS, ATM technology and aviation spectrum. Nopodol is a co-chair of the ICAO communication panel and has served as IATA nominated panel member for numerous ICAO technical panels, including frequency spectrum management. So Nopodol, if you are ready and if you can share the slide, the floor is yours.
Thank you very much, Jackie, and good morning, good evening, good afternoon, everyone. Can you see my screen?
Yes, we can see it, not yet in the full screen mode, but we can see the screen.
Hopefully it's come up soon. Let me try. Is it full screen now?
It's full screen now. Go ahead.
Okay, so first of all, thank you very much, Eurocontrol, and also our European colleagues in organizing this event. And it's very important moving forward. Communication, including SATCOM, is one of the key aspects of enhancement of air traffic management system and the CNSR application in general. So it's actually my personal pleasure to be here sharing our thought with you regarding what is the stakeholders and ally perspective. What are the key considerations that we will make in regarding to the selection of new technologies, particularly on the communication domain moving forward. In this presentation, I would touch very quickly, and I know that some of you probably hear part of this presentation earlier in earlier session on LDAX and so on. When we talk about the communication need that airlines would have into the future, in this presentation, I would touch very quickly on the air traffic services and the AOC communication, with actually two of the key quality of service required communication system that we need to have moving forward. I would touch very quickly on some of the future application on board the cockpit that require broadband connectivities and secure connectivity into the aircraft. And then at the later part of the presentation, I would touch on what is IATA view currently that we have regarding the satellite communication and some of the key considerations that we will be making as we evaluate some of the new technical solution or options that have been put on the table as we speak. So the next set of slide, maybe 2 or 3 slides, is pretty much something that we already kind of touched on in the early session when we talk about the communication need from the airlines. So that's why I would go very quickly, and my apologies for being pretty quick on speaking some of this regard. So there's two main type of communications that airlines want to make sure that we are provided with the right quality of services. The first one is air traffic services communication, ATS services, basically the communication between aircraft, pilot, and air traffic control. As everyone knows, that's require a very reliable link with the right quality of service and performance. And this is mandatory because it supports the air traffic, aircraft separations, and also many of the flight critical ATM applications. As you see in this slide, the ADSC, CPDLC, those are some of the examples of the key ATS communications that we require to have on board the aircraft. In parallel to the ATS communications, the airline's operational command and control or communication or AOC is also very important for the airline's operations. One thing I would like to bring to everyone's attention is that the use of AOC communication is very much in line at the same level of ATS communications when you're looking at the requirement under the ICAO regulations and the ITU regulations. This is our operational critical communications that airline needs, and we need to ensure that you support the communication between the airlines, the cockpit, operational, and to the operational control centers, to the ground service organization, and also quite recently, some of the engines data have become one of the more dominant players under the AOC communication. Prior to COVID, the AOC traffic have grown very fast, and that become one of the major concerns that everyone have in providing a reliable communication service to the airlines. And that's for a good reason. We have more aircraft coming in, we have more data coming out of the aircraft naturally, and some of the newer aircraft, have the engine monitoring data that need to be shared to ensure the reliabilities of the flight operations moving forward. And also, we actually use AOC for more of the flight and operational critical operation as well. So similar to the ATS, AOC also require quality of services, but at the same time, we recognize the fact that when you have more information, more data that need to be sent, that there's always a spectrum issue that need to be looking at. So before we move on and looking at some of the solution moving forward, one thing I want to emphasize is that AOC and ATS have been coexist for for a long time. From the basically when airlines start using satellite communications, the link have been used to support both AOC and ATS, and that is fully compliant with ICAO and ITU standard. One thing we recognize, however, is ATS is more time critical. Those messages need to go first. It need to be the communication between airlines and the air traffic controllers and the pilot is need to be timely and is very time critical. Some of the AOC messages have that sense of time criticalities, but some of them can wait a little bit more. So while we actually encourage the use of the same reliable link in supporting both AOC and ATS, we understand that if there's a technical solution, the message priority management is something that may help moving forward with some of this use of the joint infrastructure. Also, as I mentioned, that the use of communications and the connection to the cockpit is getting more and more prominent in some of the operations. As you see here in this picture, some of example of some of the newer applications that have been deployed quite recently. Electronic flight bag now have the connectivities with include a lot of graphic, a lot of data, the weather data that's actually quite important to aircraft operations. And also some of the newer applications would have the connectivities all the way to the flight management system, where actually used to basically manage the aircraft itself. So by that nature, there's a requirement for a higher communication throughput, that basically a higher broadband connectivities. But at the same time, cybersecurity has become the thing that need to be addressed, because these connectivities to some of the critical and safety oriented system on board the aircraft. So we need to make sure that while we need the speed and the high throughput, the securities need to come as part of the package. So now go specifically into some of the topic that SATCOM and satellite communication in general play a dominant role. I mean, naturally speaking, oceanic operation is where satellite communication is very important. As you see in this slide, in the oceanic airspace, pretty much beyond the use of our old good friend HF radio, SATCOM is pretty much the main communication infrastructure that connect the aircraft to air traffic controllers, but also the aircraft to their operational control center on the ground. So in the oceanic environment, satellite communications play a very critical role from both the safety and also the reliabilities of the flight and ATM operation in general. So in 2017, IATA on behalf of the member airlines, we actually developing a set of the user requirement that looking through all the CNS elements that are related to air traffic management services. So I just want to share with you some of the high level objective when we talk about ATS and the AOC communications. Basically, during 2017 evaluations, airlines, have agreed to support a coordinated migration into use of data link to support a primary mean of routine controllers pilot communication. And the keyword here is routine. That means that we still need the voice communication to be available for tactical interventions and for non-routine communication that exists in many part of the airspace. And this is a coordinated migration. So this is not something that everyone can expect overnight. It would have to come on the airspace by airspace basis with the right coordination. And the coordination among multidisciplinary approach and multi-stakeholder is also very important. We know that there are many players that involved in the communication chains, the airlines themselves, the aircraft and avionics manufacturers, flight crew, and aviation service provider, and also very importantly, the communication and satellite service provider. Everyone have to pretty much agree on the same timeline and the same approach moving forward. Otherwise, the communication chain cannot be complete and cannot be effective. Also, specifically onto the actual SATCOM itself, obviously the use of CPDLC is one thing that have been considered as a primary means of the communications, particularly in the oceanic airspace. Also, we're looking at the use of the voice, satellite voice in particular, as some way that can relieve the reliance on the HF communication moving forward. This is some of the expect migration that in 2017 we have evaluated and we point to. Now, with that said, now it's 2022. We passed through a global pandemic. The industry and the world look very different from 2017. But the role of the communications and the need to support AOC and ATS communication is still there. So what will be the key considerations that airlines and IATA in particular are we looking at in evaluating the next set of communication options that have been developed during the last couple of years? So in the next two slides is some of the major key criteria that we're looking at when we evaluating what communication system that we're looking forward to support. Basically, as mentioned into the slide, we want the communication system to be able to support both ATS and AOC. Common service, common infrastructure, common avionics, of course, with the right priority mechanism and the right way to ensure the cybersecurity aspect. High bandwidth, high throughput, that's obviously with the new application coming in, those are the technical requirements that need to be available. The newer application cannot run with the low speed connectivity anymore. So that is something that need to be put in place. Global standardizations and also interoperability is very important. We will hear a little bit more from ICAO, from my colleague Warren, that talk about why it's important to have some of this system under the ICAO SOP. And that would drive some of the key consideration by the airlines as well, because we want to be able to be well supported by global standards so the equipment can be used reliably throughout the globe. That link to the quality of services, that link to the performance requirement. And very importantly, those performance requirements need to be validated prior to the operational deployment, and it should be maintained throughout their life cycle. Security and prioritization is also two of the key aspects that need to be put as part of the standardization, and also hopefully that is reflected later in the MOPS and in the SOP. We also recognize that SATCOM probably not going to end up to be the only link that provide AOC and ATS communications. The capabilities of the design of the system to support multi-link connectivities is also very important. And because of the multi-link environment, the seamless media transition is something that we encourage that to be verified and validated. Spectrum, a key issue of the day. Everyone probably see the news on the 5G concern that the airlines are experiencing. So we want to make sure that any communication moving forwards is well protected under a proper technical and also the legal protections, most likely under ICAO and ITU, but at the same time, the system itself need to be designed in the right way with the right filter moving forward. So those are very important, both from the technical and legalities perspective. Cost is also still a major driving decision-making criteria under the airlines. We're still suffering the financial impact of COVID. So anything that related to investment need to be carefully thought of, and the supportive cost-benefit analysis need to be there to drive the implementation forward. So here is my last slide, is some of the key maybe way forward in when we're looking at implementing a new AOC ATS communication. Of course, the transition strategy need to be there. We cannot change things overnight in the aviation world. Everyone know that. So we need a well-defined, clearly coordinated migration path from the current system to the new system. Forward fit approach is always recommended. Once the benefit have been demonstrated, I'm sure that your customer will be looking at taking on the communications, the new communications system moving forward. Last but not least, the abilities to actually synchronize all the deployment and coordinate the implementation plan with all the stakeholders, and the capabilities to support the scale, to increase the scale of the implementation that's supported by the global interoperabilities capabilities and the global standardization is something that we look forward to. Last but not least, many of the new system, satellite communication included, can support more than just communication function. The use of position reporting through satellite communications, for certain people, we can call that a surveillance function as well. So that may be some of the things that we can look at. Of course, at the ICAO level, there would be a need to actually well define how some of this interaction of multiple CNS function would need to be looked at to avoid, putting all the eggs into one basket. but at the same time be able to benefit the robustness and the capabilities of the new system moving forward. So I know it's a lot of information, and I'll go through this very quickly, but hopefully that set the scene of what are the airspace user, particularly the airlines, what are we looking at, what are the key considerations moving forward as new satellite communication system being developed. So I think that concludes my presentation. I would like to thank you again, everyone, for attention, and thank you, Jackie, for organizing this. And I'll pass the floor back to you. Thank you.
Thank you very much, Nopodol. It's very important to have the view of the airspace users, because one of the key stakeholders in this communication system. I see that we have already a lot of questions regarding the SATCOM, whether we can use commercial off-the-shelf services instead of dedicated system, how to address the security, what about ATN-SI protocol. Before going to all these questions, I will suggest to go to the second presentation, at which you will have already a large number of answers to this question. I will pass the floor to Martina. Martina, while you are starting sharing your screen, I will introduce yourself quickly. Martina is earning a Master of Degrees in Telecommunication Engineering for University of Pisa in Italy in 2008. She joined the European Space Agency in 2010 as a communication system engineer in the radio frequency payload system division of the Technology Directorate. She has been responsible for several advanced research in telecommunication system projects, mainly in the context of the ARTES project at the European Space Agency. Since August 2018, she joined the ESA Telecommunication and Integrated Application Directorate with the role of system engineer in the IRIS, where she is responsible for all the system aspects concerning IRIS project implementation. She is also involved into several aviation standardization groups within Eurocarrier ICAO, as well as the Eurocontrol FCI task force, where she's contributing to the future SATCOM data link technology, including the FCI business case that we are developing for the time being. Martina, welcome. Thanks for participating. The floor is yours for the ESA presentation.
Thank you, Jackie. Can you hear me well?
Yes, we can hear you well. Go ahead.
Okay. Thank you for the introduction. Good afternoon or good morning, everyone. So we're going to provide an overview of SATCOM systems and services for aviation communications, and also on the role of SATCOM for integrated CNS services. So the structure of the presentation will not spend too much time, but I would like to introduce again the aviation communication services, mainly highlighting how the requirements of the services can act as design drivers whenever we go to take design choices. Then we'll see how SATCOM can be classified and characterized on a qualitative basis, very high level, followed by a list of existing and future SATCOM systems and services, focusing on what are the developments, both from a system and technology point of view at the European Space Agency, then SATCOM for CNS, and conclusions. So as you have just seen in the previous presentation, aviation communication services can be divided and classified in different domains, mainly recognizing whether they are for cabin or for cockpit. So starting from the most critical safety services, we can see that the cockpit-related and so-called aircraft control domain is the domain with the most stringent requirements. The ACD consists of systems and networks whose primary functions are to support the safe operations of the aircraft. So ACD connects to high-priority safety communications, such as those supporting air traffic services, or ATS, and some of the airline operation communications to the cockpit. So the table that you see below, I will not go into the details, but basically summarizes the main elements into this critical domain, including cockpit voice. And what I would like to highlight is mainly related, for example, to the ATS services, which are safety and time critical, like CPDLC and ADSC, that have therefore safety requirements, reliability, continuity, availability, and integrity requirements. They require possibly segregation and prioritization of other services, and they have stringent latency performance requirements. On the other hand, they normally do not present very high data rates, while, for example, EOC data can present higher data rates. So if we look from a system point of view, these services have an impact in terms of requirements on having a secure system with low latency, possibly an efficient access scheme, a redundant system in order to ensure availability, and a global system in order to ensure continuity. Very quickly, other domains like AISD, our Airline Information Service domain. It basically contains airline administrative and non-safety related communications and the data for operation of the aircraft, which are important but not critical or essential, and therefore not safety critical. An example is the electronic flight bag, and some type of information are the weather data and also the engine data, for example, that are very large amount of data, more and more, as presented before. So if we look at the requirements of this kind of service, for sure, the integrity and availability requirements are still there to ensure some quality of service, but are less stringent than the ATS services, while data rate is quite high. We can therefore talk about latency tolerant services, but for sure, services that require high capacity and bandwidth. Last but not least, passenger information and entertainment domain. We are moving directly to the cabin. So it's cabin connectivity, providing for the passengers connectivity for communications and entertainment. It's definitely non-safety services. They require, again, certain quality of service for the passengers, but they cannot be considered critical. So we can again point to the need for high capacity in this case. So we are diving now into the SATCOM world and how this fits into the aviation safety today. Satellite communications are today widely used in operation in oceanic airspace, and are becoming also a more and more important complementary component for continental aeronautical communications. Actually, the future communications infrastructure and also the ATM master plan have already identified SATCOM as a key complementary component to meet the current and future aviation data link communication needs. Now, existing systems like Inmarsat and Iridium are SATCOM systems that are or will be operational and compliant with the ICAO standards and recommended practices, or SARs. In particular, Inmarsat Iris is already ready for deployment, while Iridium Certus service, which is based on the Iridium Next constellation, is also expected to offer in the future AMSRS services. Now, I would like to provide a very high level and really qualitative type of characterization of the SATCOM systems in order to give you the perception on how the satellite communications can be used, and among them which is best to use, pros and cons trade-offs for aviation communications in relation to the requirements that we have just seen, starting from the frequency bands. So I reported here some of the main frequency bands in the aeronautical communications, and I would like to start from the frequency allocation matter. So VHF, L-band, and C-band have what is called a primary allocation within the frequency spectrum for AMSRS services, or aeronautical, mobile, satellite, and route services, which are basically all the services that we've seen in the ATS domain as safety critical. The portions of those bandwidths in these areas of frequencies that are used for aviation communications are actually larger than the primary allocation, but for sure having a primary allocation, which means having some sort of priority over that specific portion of bandwidth, ensures some protection. In KU and KA band, the allocation is possible, but it has to be shared with the current existing mobile satellite and fixed satellite systems and services, MSS and FSS. Coming instead to the aspect of the atmospheric impairments, I think it's important to mention that for what concerns lower frequencies, so like VHF, L-band, and C-band, the atmospheric losses are very low. So below 1 dB or maximum to 3 dB in C-band, especially depending on where we are on the Earth surface, are definitely low. The situation is different for KU and KA band, where the losses can reach up to 20 dB. And in this case, fading mitigation techniques are not only recommended, are needed. I reported here adaptive coding and modulation, because indeed some contrast to ensure to close the link, to some techniques to ensure to close the link is needed in this case. So having said that, for sure, we can say that VHF, L-band, and C-band from this aspect represent an appropriate solution for high availability, to comply with high availability requirements. very briefly. For what concerns capacity, capacity normally increases when we go to higher frequency bands, simply because there is normally more bandwidth available. Terminal antenna, we can see that for a given terminal antenna size, the directivity increases, and so does the gain, for moving to higher frequency. If we shift the point of view from another side and we want to target a specific gain, then we'll need a larger antenna instead, going to lower frequency. So the antenna size increases for moving down to lower frequencies. Same consideration, of course, for the satellite antenna. Just mentioning that multi-beam system from satellite is normally needed to be able to reuse the frequency, which is key to get a certain capacity, both over the various, also over time, we can move resources, but also over the coverage, especially when dealing with traffic that moves over the coverage. So we'll need a larger satellite antenna for having this multi-beam at lower bands with respect to KU and KA band. Now, I would like to shift to another point of view, still following up this high-level classification or trade-offs of SATCOM systems. So speaking about orbits, I think most of people maybe know what is a GEO or a MEO or LEO, but basically the characterization in terms of orbits is done, first of all, by the altitude. So geostationary satellites are normally placed at 36,000 kilometers, while medium Earth or low Earth orbit satellites are below that altitude. LEO can have, for example, various altitudes, but even very low with respect to the GEO and close to the Earth surface. So the service area, first of all, is one of the first components that is worth to mention, because in all the types of systems that we are showing here, MEO, GEO, and LEO, is global. For GEO systems, a global coverage can be reached with only 3 satellites, but is normally limited between plus or minus 70 degrees. While the advantage in this sense in MEO and LEO systems is that as they have lower orbits, the satellites are moving, and therefore they are providing global coverage, including poles. MEO normally requires about 6 satellites to have a global coverage, while LEO many more satellites. So another aspect that we touch based on this, we touch in this qualitative assessment is the ground segment complexity. So we can say that the complexity of the ground segment grows whenever we move from geostationary to MEO or LEO systems, simply because the ground stations need to take into account that they will need to have satellite handover mechanisms, and therefore they will need steerable antennas. For what concerns the terminals, for example, also the Doppler effect somehow grows whenever we move to LEO constellations, because on top of the aircraft, we need to consider also the movement of the satellite. Operational system complexity. This is also increasing going to constellations with lower orbits for similar reasons, because there is quite a large number of satellites to be managed at system level, and often inter-satellite links and traffic routing is part of the game as well. For what concerns latency, latency is higher for geostationary satellite systems because they are higher, so the path is longer, and it can be considered around 500 milliseconds two-way, while it, of course, latency decreases while going to lower orbits, reaching down to 10 or 50 milliseconds in the case of LEO systems. But these numbers are not including, it's important to mention, the processing delays, which are raising up by 200, 300 milliseconds, normally the whole amount. Last but not least, capacity. All the SATCOM systems normally are able to provide very large capacities. GEO and MEO systems already providing 1 terabit per second are existing. I think it's worth mentioning that with the new trend for mega constellations, the capacity can be pushed up to even few tens of terabit per second. Now, let's have a look again more in specific to the future communication infrastructure. So the FCI will provide ATS and AUC data link, initially using the existing systems, which are also based on the satellite technology called SATCOM Class B, to allow for supporting the initial 4-dimension I4D operations and ATS-B2 service. But on the long term, the SCI is targeting to include technologies complementing initially the VDL Mode 2 and then operating also in multi-link among them, and especially SATCOM, which is the topic of today, LDAX, which is the terrestrial L-band OFDM-based system, and the Aeromax, which together with 4G and 5G will operate in the proximity of airports. In the picture, we're also starting to consider in the FCI the so-called off-the-shelf, so existing systems. The FCI is targeting to have global seamless support of 4D and trajectory-based operations, which I would like to mention is a key component for the ATM modernization in order to allow for greener aviation, for greener skies. There is a rising attention to this aspect, especially if we consider that before COVID, aviation was, if aviation were, the global aviation were a country, it could have been ranking among the first 10 emitters. This was before COVID, but even now we can see that the projections for the flight are raising again. So we really need to take action and optimize the flight routes as much as possible in order to reduce fuel, delays, and consequently CO2 emissions. These technologies are going to be based on ATN IPS infrastructure and compliant with ATS-B3 performance, and interoperability with legacy ATN OSI systems needs to be guaranteed. Currently, in the SESAR Wave 2 PJ14, Solution 77 is validating at network level these various technologies, while in specific for SATCOM, Solution 107 is targeting the development and validation of SATCOM Class A. At present, the IRIS solution, which is the part of the ESA program, based on SATCOM Class B, is ready for deployment and approaching pre-commercial flights. So I will not spend too much, I will not say too many details about the IRIS program, which is a collaboration between ESA and Inmarsat, because IRIS is going to be object of the second and third webinar, as already introduced by Jackie. So the second webinar will cover its technological aspects, and the third webinar on SATCOM maturity will also cover IRIS maturity. So coming back to Inmarsat system, classic aero and ship broadband safety are certified services for Oceanic, and they provide global coverage, fully redundant and cyber secure, compliant with the 99% availability requirements. So they provide safety communications like FANS1A, CPDLC, and ADSC, airline operations, an example is the electronic flight bag, and IP voice. These services are based and provided on the I4 constellation plus AlphaSat, and now also I6 is lately being launched. But the portfolio includes also Wi-Fi in-flight entertainment, based, however, on the GX satellite, and also UAVs connectivity. For what concerns IRIS is the future of aviation communications for safety, especially. So it will provide safe, secure, and efficient ATM communications in continental Europe, ready for pre-commercial flights in 2022. That's the target, and targeting entry into service in mid-2023. IRIS builds on the Inmarsat SATCOM infrastructure, as we said, AlphaSat and I4, mainly at the moment. Legacy SBS services and capabilities for Oceanic will be maintained, adding new capabilities to introduce continental ATN OSI operations, enabling I4D and contributing to the ATN modernization. Ongoing developments for ATN IPS are also being validated in collaboration with the SESAR solution 77 and 107 of PJ14. Passing to the other system, mainly active in the safety services, Iridium. Iridium Certus is a multi-service platform, offering, among others, also cockpit voice and in-flight aircraft communications like FAMS data services, AUC, weather information, but in general, electronic flight bag service. Iridium is working for the introduction of AMSRS services, targeting to provide ATN B1 and B2 services via IP, in line with the PBCS performance, still ICAO standards. Of course, being an L-band system is weather resilient, It has a global coverage and it provides low latency being a LEO. And I think it's worth mentioning that it hosts, as a system, various hosted payloads. Among them, we can mention Aerion safety service for, it's not really safety, surveillance service, sorry, for ADS-B. So I would like now to go very quickly through some of the examples of SATCOM systems for in-flight connectivity. So we are now moving to the passenger information and entertainment domain. And there is really a wide multitude of companies offering this kind of services. Here I will just briefly mention a few. So for example, GoGo, which whose communication for aviation part has been acquired by Intelsat, provides in-flight Wi-Fi connectivity in Ku and C-band, targeting 5G and IoT via satellite. IoT stands for Internet of Things, one of the trends. Panasonic Avionics also is a service provider which, in partnership with the main, with some of the main satellite operators, relies on Ku and Ka-band geosystems to provide in-flight connectivity, as well as Seatown Air that provide passengers connectivity in partnership with Inmarsat, I think, among others, both for L-band and Ka-band geostationary satellites. Then operators like Viasat and also Eutelsat are providing directly services for in-flight connectivity. Viasat, for example, is also offering electronic flight bag and real-time weather and digital documents management services for the crew. So these are just examples. I went really quickly through them. While I would like now to go through potential SATCOM systems that could be complementing safety services for in-flight connectivity or maybe airline connectivity in the future. Mostly from a system point of view, it's interesting to see the trend for mega constellations, and that's why I would like to mention Starlink in Ku-band LEO system, as most of you know, and also OneWeb, with whom we also have a partnership with ESA for the next generation constellation of satellites to be, and the current constellation, actually the mega constellation, is going to be completed by 2022. Another example, still an initiative together with, in collaboration with ESA, is the ATS Space Mobile initiative, which is using LEO system in UHF and S-band to provide 5 or 4G services, building a mega constellation in LEO, and using again these frequencies of UHF and S-band. Another activity that is worth mentioning is the satellite-based VHF that Indra and IRA are, in collaboration with SESAR Research and Innovation, investigating to provide voice and data link extension over oceanic, integrated with service of surveillance. Now, I would like to focus on what are the ESA activities that are currently ongoing or planned, which are maybe not directly related to aviation, but definitely are relevant in this context, both from a SATCOM system and SATCOM technology point of view. So we are looking at the design and consolidation of next generation SATCOM system for secure EU connectivity in order to support it. And as well, we are looking at how to enable, by means of ESA-initiated and also industry-initiated activities, the sharing of commercial and governmental SATCOM resources. At the same time, development of next-generation commercial constellations is going on. I already mentioned the one of OneWeb for mega constellation. Next generation of CNS solutions is being investigated, especially addressing the possible new surveillance solutions. And I hope you've seen that there is the possibility and the trend also to consider multi-orbit systems. Actually, the flexibility to have multiple system configuration in this sense is one of the key features of satellites. And geo and non-geo systems could be considered to have also Arctic coverage. And this is one of the things that we are looking at. From the technological point of view, among others, the developments ongoing are targeting multi-band and multi-orbit elements at the ground segment, like antennas, airborne antennas and ground antennas, and also terminals. Still talking about the possibility of having a multi-orbit system, anti-jamming solution in general is always needed, but also tools that allow for interference analysis of coexistence of geo and non-geo satellite systems. Also, the trend of the 5G and even 6G is being investigated and further developed by developing elements to sustain the interoperability of these systems with other existing systems, and also multi-frequency band technological elements, both on ground and in general for a wide range of applications. Specifically talking about applications, in the application domain, there is really a wide range of applications using satellite and space infrastructure. Definitely worth mentioning in the context of aviation is the virtual black box, but also weather dashboards, drones applications, space-enabled digital and green economy. Special attention to the green economy is being given, especially in the latest times. So, very briefly, satellite for integrated CNS services. The communication aspects we have been already mentioning. ESA is working on the IRIS program, providing the communication for the cockpit. And it's a satellite-based data link. I will not go further into details, but basically, of course, it's satellite-based. As well as surveillance services like ADS-B. We already mentioned the Aerion service based on the Iridium Next constellation. It basically provides the space-based automatic dependent surveillance broadcast. For what concerns also a new ESA initiative, it's worth mentioning that we are investigating solutions for independent cooperative surveillance. Navigation. I think most of people are familiar with the GNSS service of Europe, which is Galileo, developed by European Space Agency for the European Commission, and also the augmentation system EGNOS. So all of these areas, of course, goes without saying, have in common the satellite element. So I would like to bring you now to the conclusions at the end of my presentation. So basically, we've seen that air traffic services, critical and safety critical services, present stringent requirements in terms of safety, reliability, continuity, availability, integrity, and latency. This results in the need for low latency systems, efficient access schemes, and most of all, secured communication systems. Which is really one of the characteristics of the SATCOM systems, available on a global scale. So we've seen, and I hope I managed to pass the main messages of the flexibility and the possibility of having multiple orbit, multiple frequency in satellites. But basically, SATCOM is intrinsically compliant with this set of requirements, even with the latency, because of course, the path is longer with respect to terrestrial systems, but it's still compatible with the requirements. And satellite indeed is ubiquitous because the coverage is global, it's scalable, flexible, as I explained, secured and resilient. Satellites represent a key FCI complementary component, among others, and it will be able to bring I4D operations in the short term and enable TBO trajectory-based operations on the long term. SATCOM will have a key role as an interoperable element for multi-service approach, especially offering segregation for critical services, and also acting as an element for integrated CNS service. It will be able to enable multi-orbit and multi-frequency systems, and ESA is actually actively working on technological developments to support this trend. I would like to just conclude mentioning that the satellite cost hopefully will reach a level that today that will make it a viable option, considering also its benefits. I didn't talk about the cost during the presentations, but basically this trend for mega constellations has generally pushed to have manufacturing costs and also launching costs being lowered. So that's an element also that I think is worth mentioning. And this concludes my presentation. I'm afraid I overrun a bit, so I'll conclude here. Thank you. Flora, back to you, Jackie.
Thank you very much, Martina, for this very complete presentation on the SATCOM. It's a very nice overview. It's a lot of information. It's a lot of things to digest. I see that there are a lot of questions on the chat on the latency and depending on the number of the gateway that you have to pass through and so on. I think we will come back to this question, but I see that there are some people from Iridium that are answering to the particular question already in the chat, which is good. Martina, you mentioned rightly the ICAO standard. So the next speaker will be about ICAO, and it's our colleague Vaughan Mayola. Vaughan has worked, you know him already, for almost 40 years in the field of aviation communication. Prior to joining ICAO, he held various roles with communication service provider SITA and the Austrian Civil Aviation Authority. He's currently serving as the secretary of the ICAO communication panels, and he will provide us with a brief overview of the current situation of satellite matters at ICAO. Vaughan, you can start sharing your screen and move forward through your presentation. Thank you for being with us.
Great, thank you, Jackie. I'll just go into presentation mode and then I will commence. Very good. Okay, well, I'll begin by thanking Eurocontrol and Jackie Houzé for arranging this series of webinars on SATCOM for aviation. I think we're about to enter a very exciting period, and I think it's important that people are informed about the possibilities that we will see in the near future, because that will benefit civil aviation in general. I'd also like to thank the previous speakers, because they've given us a lot of very useful information so far today. And from my point of view, they've made my job during this session a lot easier. So thank you. Now, Jackie did introduce me, so I won't go over my details again. But I will say that for my part of today's briefing, I'll be giving the ICAO view on SATCOM for aviation, or more specifically, what ICAO is doing with regard to standardization of the current SATCOM services and the ones that are imminent, the ones that are coming. Regarding standardization, I think many of you would be aware that the industry standards making organisations have been active for well over 2 decades. If we go back to the late 80s, ARIC produced the 741 specification. Since then, they've produced 781, 791, and a raft of others. Inmarsat have gone through a number of editions of their system definition manual, and RTCA and EUROCAE have produced a large number of documents, starting with DO 210. Since then, there's been 215, 270, and we have the EUROCAE documents as well. So given all of that, where does ICAO fit in? Well, to answer that question, I need to digress a little and talk a little bit about the ICAO documentation hierarchy. I know that's a mouthful, but I think there's a lot of confusion about the role of ICAO and the standards that it produces. So hopefully I'll clarify some of that today. The hierarchy is shown here in the bottom left corner. And at the very top, you have the Chicago Convention. That is an international agreement between ICAO and its signatory states, nation states in other words. And it outlines the roles and responsibilities of ICAO and the signatory states. If we go down a level, we have the annexes, and these two are part of the convention. So if something is in the annex, it is binding upon ICAO and the signatory states. The annexes actually contain what are known as STARPs, Standards and Recommended Practices. And the standards actually become regulations in the signatory states. They become law for all intents and purposes. So they're binding, they're enforceable. But as we go down, there are different documents. There are PANs, Procedures for Air Navigation Services, supplements where there are deviations from that, but they're operational documents. I won't go into those today because they're outside of the scope of today's presentation. At the bottom, we have guidance documents. Now, these can be called various things. Sometimes they bear the title technical manual on a given subject. Other times they can be called technical specification on a given subject. Other times they're just simply called guidance on a given subject. So because they are unenforceable, they are just called guidance documents. They offer guidance. Now, I'll just go back to the top again. If we look at the annexes, there are some 19 annexes covering a raft of subjects, and everything from aircraft markings to personnel licensing provisions to air traffic management procedures, safety and security, and so forth. There are 19 annexes. Of those, there is one, Annex 10, which covers CNS, Communications, Navigation and Surveillance Systems. That's quite a large annex. It actually is divided into 5 volumes, one dealing with navigation systems, the other dealing with surveillance systems. They all come under the umbrella of aeronautical telecommunications. Another, of course, dealing specifically with telecommunications, which is Volume 3 of Annex 10, which is the one that deals with SATCOM standardization. As well as that, there's another volume which deals with spectrum or frequency regulation. And there's soon to be a 6th volume dealing with the command and control link for remotely piloted aircraft systems. So that's a fairly critical document. Now, I did say that the contents of the annexes become regulations. They become mandatory. But Annex 10 is a little bit different. When we're dealing with an annex that covers such things as aircraft markings or runway lighting and so forth, those things have to be uniform around the world and they all have to be implemented. However, with CNS systems, you don't implement them unless you need them, unless your air traffic justifies an expansion of your navigation capabilities, this sort of thing. Not everyone needs the full raft of, say, aeronautical navigation ground aids, for example. Not everyone needs the whole battery of potential aeronautical communication systems. So you might say, well, what good's the annex? Well, really what it says is, with regard to CNS systems, Annex 10, yes, it does specify strict requirements, but what it says is if you need to implement a given capability, you must do it this way to ensure minimum levels of performance and global interoperability. Now, I'll just move on to the guidance documents, and I'll talk a lot more about those in a few minutes. But the guidance documents provide information on a number of things. First and foremost, their role is to explain how to implement given systems, surveillance systems, navigation systems, communication systems, and manage and operate them in such a way that they do meet the requirements of the SARPs. You have to remember here, the SARPs become regulations. They're very high-level requirements. Another role of the guidance documents is to provide a lot more detail on the system function and operation. A lot of the industry standards are very prescriptive technical specifications. To the average reader, they don't really convey a lot of information about how a system performs or functions. And hopefully the ICAO guidance documents go some way to filling that gap. And as you'll see in a few moments, they will certainly need to do more in that regard in the future. So just a little bit more on standardization. So where does ICAO fit in today? Well, right now, there is a project team under the communications panel, which is busy updating the SARPs and guidance to accommodate the next generation satellite systems. Now, these next generation systems are pretty exciting. Their performance is an order of magnitude better than what was achievable with the older classic systems, which we're all familiar with. They actually open the way for SATCOM to be a viable communication medium in busy domestic airspace. In some cases as a primary means of communication, in other cases as a secondary or tertiary backup. And this is a great development because ultimately it means we'll have more robust communications and we'll have more communications options. Specifically, what ICAO is doing is updating the Annex 10 SARPs in Volume 3 and Document 9925, which is the manual on SATCOM aeronautical communications. Now, again, the question is probably still in some of your minds, and that is, why bother with all of this when we have all these industry standards that I mentioned? Well, first of all, the industry standards themselves are not regulations. They are often very detailed technical documents. And they're not necessarily a handbook advising the ground users, typically air navigation service providers, what to do, how to make a system work. Now, with satellite communications, typically it is provided by a third-party supplier. Today we have Inmarsat and Iridium. As was pointed out by a previous speaker, there are many other potential providers in the future. And every one of them has a system that's got a very different nature, different characteristics. And of course, a potential customer, an ANSP, an air navigation service provider, needs to know what to ask their provider to give them. They need to hold them accountable as well, because we are talking about safety communications. So the guidance material needs to tell both airlines and air navigation service providers what to demand from their communication service provider. It also needs to tell them what to put in a service level agreement. A lot of the communication providers they're multi-service providers. They don't just look after aviation. They could be looking after, in terms of aviation, they could be looking after passenger communication, passenger entertainment. They could be looking after the maritime industry. They could be looking after news gathering agencies. There's a whole raft of services that they provide. And the reality is, the harsh commercial reality is that they make more money from that. So they have to be bound to offer a high grade of service for aviation. And that's where the service level agreements come in. And of course, states will need guidance on how to construct an adequate service level agreement. Information on that is already given in the Gold Manual, which many of you will probably be familiar with. We need to expand on that information in future guidance material. Another key thing is interoperability. We need to ensure that access is non-discriminatory. That is, that an air navigation service provider can communicate with all aircraft in their airspace. But as you've seen a little earlier, the airlines can potentially get service from a number of different carriers. Today, they're largely limited to Inmarsat and Iridium, but that will change in the near future. How does a single ANSP manage that communications? Well, we need rules to ensure that the providers interoperate. Now, I'd like to talk a little bit more about the future, or where we're going to in the future. Now, NX 10 will continue to support national regulations. That is, it'll provide minimum performance requirements as they evolve. They will become more stringent in the future as things like dynamic RMP or interval management and other advanced operational services come into reality. They also will need to support other regulatory obligations, such as the ITU radio regulations. And this is important, as was touched on by the speaker from IATA, my colleague Noppadol. Aviation has been very fortunate in that it has a lot of spectrum allocated to it across multiple bands. But there is this ongoing obligation to be an efficient user of that spectrum. And if we're not efficient users of that spectrum, we will lose it. It will be taken from us. So we need to ensure that future systems that we implement make good use of that spectrum. They use that spectrum efficiently, because if we don't, it will be taken from us and given to the mobile telecommunications sector of industry. And that would be tragic for aviation. Another role of the SARPs in the future will be to provide the minimum requirements to support interoperability. And that will become more challenging as more and more satellite providers become available. Now, the guidance documents themselves, they will need to do a lot more though. Their main role will be to provide information on the integration of SATCOM or any communications technology into the communication chain. As the previous speaker explained, there is a concept which is particularly popular in Europe, the future communications infrastructure, which talks about the integration of many different communications media to provide a complex fabric of communication means for civil aviation. Now, what we'll have to do in the guidance and the material is steer people towards using a common interface. That common interface in the future will be the aeronautical telecommunications network using the Internet Protocol Suite. We're not there yet, and you will see a roadmap presented later showing that as the end state for communications, which we should achieve later in this decade. Another key thing that needs to be covered is a clear description of the roles of the communication service providers, the satellite service providers, and others in terms that provide useful guidance to the ANSPs and aircraft operators. The communication chain that we have is actually quite long and complex for SATCOM. We have the avionics and the aircraft, and they're sourced by the airline, and they could come from a number of different vendors. That airline will contract with the satellite service provider. That's the SSP that you see mentioned there. Now, the satellite service provider provides, yes, a satellite and a ground earth station. Now, how does the communication get from the ground earth station to the ANSP, or the airline for that matter? Well, they will contract with a communication service provider. The two most well-known today are Eric and SESAR. And their job is to provide the ground segment and also to integrate the communications. Eric and SESAR today both support VHF and satellite communications. They both support satellite communications via Iridium and Inmarsat. So their job is to actually guarantee interoperability and provide a whole raft of services via one connection, or rather one single service contract. The roles and responsibilities of each in the communication chain needs to be understood by the end user to assist with things like troubleshooting, what we call it, contractual issues. How do you determine who is at fault when the performance that you've been given is not adequate? This sort of information needs to be put in the guidance documents. So to summarise it all, to sum it all up, the guidance will need to have specific information on the new technologies, the new SATCOM technologies, their limits, the limits of those technologies, because as you've seen, they vary dramatically. And this was really pointed out quite vividly in the last presentation. The other thing that's important, just from a layman's point of view, is this, that these different satellite technologies fail differently. A failure of a geostationary system is quite different and has different effects to a failure within, say, one of these multi-satellite LEO systems. Ground users need to understand that, because you have to remember there are 193 states, all with different levels of technical capability. And we've got to try and bring them to the same level. And so that's why guidance material will be critical in the future. And another key thing is that we've got to be able to validate these service providers to ensure that the performance they provide is adequate for a safety-related service such as air traffic control. So I think I've probably exceeded the time allocated to me, and there are a number of other speakers waiting, so I hope to deprive them of their important slot today. So with that, I'll end now and hand back to you, Jackie. Thank you.
Thank you very much, Vaughan, I think, for this very interesting and comprehensive presentation and the role of the Annex 10. And I think there are two key important that I would like to underline in your presentation is the interoperability and the spectrum, that we can see what's going on with the 5G and the telecom world for the time being with aviation. So I think they are important. Looking at the time and being the moderator, I have to watch. So I have to admit that we are slightly late for the presentation. So I will have the next speaker to go relatively quickly because I would like to have half an hour the question and answer at the end of these presentations. The next speaker will be Ruben Flor from the SGU. Ruben has been working as ATM expert at the SESAR joint undertaking for the last 10 years. As such, he guides the R&D project on all innovation aspects related to system-wide information management, so-called SWIM, cybersecurity, communication, navigation, and surveillance. He has been a long-standing career in aviation and also at KLM flight planning system developments, such as Dutch air traffic control system development, as well as aviation consultancy. So Ruben, I'll give you the floor to provide us with the SGU view on SATCOM. So you can start sharing your screen. Normally it should work. Perfect. Ruben, we cannot hear you.
Sorry, new try.
Much better now.
Okay, thank you again, Jackie. So upfront, just one, I think, quite important remark, which is that I need to thank Martina for having done an excellent job on presenting and taking about half of my slides that I don't need to present anymore. So you did a good job. I'm going to be brief on that, so I'm not going to take more than 10 minutes, probably a little less. What I'm going to do, though, is put a bit of perspective or the context, let's say, of the SATCOM development that we see and put it in a bigger perspective of aviation satellite services in the R&D activities that we do in SESAR. So very high level academic as a little warm up, just why would we want to go from terrestrial to space-based? So the first is very obvious, I would say. So if there's no terrestrial option available, there's an ocean, very remote areas, the polars, for example, that would be a good reason for going to space-based. But there are actually other considerations as well. So performance is one quite important. So can we increase reliability? Can we make it more scalable? Can we increase capacity? Can we make it more resilient? Can we have a better latency? Can we introduce cybersecurity that we didn't have before? So those are all questions that we need to look at when we look at space-based solutions. Also, we look at higher cost efficiency. Maybe not the first thing that you think about when you think a couple of decades back about launching satellites, but actually, if you look at new space solutions, satellite technology is becoming cheaper and cheaper. And on top of that, if you look, for example, the GNSS, the satellites, well, also for communications, actually, the satellites are actually shared resources, not only dedicated for aviation, but they are used across multiple domains. So actually the launching of satellites, the maintenance, the operations, the costs of that are also shared. So it could actually be cost efficient compared to terrestrial infrastructure. Last, also higher spectrum efficiency, in particular because from a satellite perspective, you can cover much bigger services compared to what's from a terrestrial perspective you could cover. So that's very generic. This slide is the one that one of the slides that Martina already explained. Excellent, I think. So the differentiation between GEO, MEO, LEO satellites. I show here some examples. And you see that on navigation, communication, and surveillance, all of that is actually already happening in space. And I think in terms of the distance, also already that Martina mentioned as well, quite good. There are a couple of things that have an influence that you need to take into consideration when looking at which kind of satellite makes sense to use, which is, where is it geostationary? What is the coverage? What is the rotation time? Impact of Doppler effect, transition time, latency, and also the further away from Earth, the more potential disruptions there are, in particular from solar activity. So I'm going to zoom in on each of the three different areas: communication, navigation, surveillance. Although I do acknowledge that the emphasis is on communication, so I'll elaborate a bit more on the communication compared to the other two areas. So on the operational needs, first of all, I think we have to start with air traffic control. So there are two different aspects to it. So one is the voice, which is the RT or VHF radio, but it could actually, although VHF might originally be analog, it could actually also become digital in the future. And then the data link. So CPDLC was already mentioned before, the ADC EPP downlink. So it's the trajectory prediction from the FMS down to the ground, to air traffic control, which is what is illustrated here on the right side. So if you have a control loop or a closed loop cycle where you downlink what the FMS thinks it's going to do and uplink what the air traffic control wants to do. So this is called here full 4D, but it starts today with the CPDLC message, but we are working on what we call complex clearances to, let's say, add or uplink the first next set of constraints, vertical or lateral constraints to an aircraft to deconflict trajectories. Having said that, indeed, ATC is not everything. In particular, AOC is also becoming more and more important in terms of data exchange. Well, there is also, again, voice, the SOT voice for Oceanic, which is going to replace the HF. Then also more and more important, the electronic flight back, which can much more detailed than with the previous ACARS messages, give high resolution pictures and information on meteorological information, aeronautical information, but also network management information, passenger services and non-critical cabin data, but also flight engineering data. In particular, if you look at the newest airframes, you see that the need to downlink and continuously airborne downlink flight engineering data becomes more and more. And to be actually fair is that if you look at the VDL mode 2 congestion issues that we have currently, which is one of the reasons that the CPDLC is sometimes a bit slow, is actually that the channel is being used and shared between ATC and AOC. And as AOC is increasing, you actually see that it's clogging a bit the data link. On top of that, we're also looking at new entrants, so U-space and high altitude operations, which means that this is still a question mark. We don't really know what's going to happen there. There's still quite some research going on. Well, I guess you can't see here the link. We had another SESAR digital data link on U-space consolidation of the most recent R&D results. There is a link there when the presentation will be shared that links you to previous webinars on that topic. One thing relevant to know is that so the different applications here, operational applications, have different quality of service needs in terms of reliability, latency. And one of the ways to address that, to avoid the situation that we currently have with VDL mode 2, is to introduce a mechanism of message prioritization. On top, when we look at future R&D for communication, we also look at authentication and encryption. And both of that is actually also a pretty straightforward justification for moving towards IPS. So this is what we have in mind when we look at the complete architecture. So here you see the SATCOM Class A and Class B that were explained before. But in the bigger picture, we're also looking at terrestrial infrastructure, the LDACs. Again, there was a previous webinar on that. There is a link on that in this presentation somewhere as well. And Aeromax, the airport Wi-Fi. And we're also looking, and I'm going to zoom into that in the next slide, what we call a hyper-connected project, which is looking at the usage of commercial or public networks to use for safety critical purposes. Not obvious, but we're investigating. So all of that coming together in a multi-link, which would seamlessly switch between whichever network is available, looking at quality of service needs, so performance-driven link management. So this is what we call multi-link. It's one of the projects that we have running, and next year it should reach TRL 6, which is ready for industrialization and deployment. I think already mentioned, but the most important thing here is the message prioritization security and the fact that it's performance-driven switching between different links and moving or supporting the migration towards IPS. So all of that will ensure that because basically it means that you can use from an aircraft perspective, whatever link is available, that you increase resilience. LDACs, I can be very brief on that. We had a webinar on that before under the umbrella of the JCSP. So this is the terrestrial technological pillar that we're looking at. One of the important elements here is that we're not looking here just for data link communications, but also investigating the possibility to use this as alternative positioning, so alternative navigation, if you want, as a backup in case there are issues with the space-based components. This is the SATCOM. Again, not much need to explain because Martina already did an excellent job. I think the most important part that I would like to mention here is the fact that if you want to validate, or if you look at the whole architecture of SATCOM, you have to understand that there is actually not only a space segment, but it also has the airborne segment and a ground segment to do the routing all the way to the either AOC or the ATC. And if you validate, you need to look at all of that together. So this is why we have this collaboration between SESAR and European Space Agency. And you'll also see that the validation that we do on SATCOM is also integrated back into what we have here, the multi-link. So in our validations, including in the multi-link, we will actually also use the prototypes that we have for SATCOM to make sure that, to demonstrate that it all works together. So this is the hyper-connected. We're looking here at integration of open network services, commercial public radio links and technologies into the safety critical domain. So the fact that you can actually just connect it is, I think, maybe relatively straightforward, but to build the safety case is actually here the hardest part, not having the stringent quality of service requirements that we have for our safety critical networks. We are basically looking at two use cases here. One is as a backup to the safety critical networks. So on the left, the backup, which it could include the KU, KA bands, satellites, but also any other 4G, 5G solution, airport Wi-Fi, other new space, for example, LEO solutions. And the second use case is to actually run through this with the idea that if we have the availability of multiple channels that we could choose from, that actually you could still build a safety case by being able to seamlessly switch between whatever is available. This is ongoing work, very different from the others. This is targeting only TRL2. So this is really focusing on the safety case to investigate whether this is feasible or not. One more project relevant on the R&D side in terms of space-based applications, which is the very large-scale demo voice, which is using low-orbit satellites that can transmit VHF communications with the idea to combine that as well with space-based ADS-B and to demonstrate with that we can control traffic in remote airspace, oceanic, for example, the way we do terrestrial. So normally, if you look at the blue operations that we have, the figure is maybe a bit complicated to read, but basically it says that if we have very low response times or long transmission times, whether it's for surveillance or for communications, it means that your separation has to be long. So this is what we do. Oceanic separation is procedural separation. And if you look at the TMA, you have very short or very high stringent quality of service requirements. So what we're looking at is, can we move that oceanic a bit more to the left, or maybe all the way to the left? And at the same time, if we have a VHF satellite-based, and one of the important things here is without actually changing the radios on the airborne side, then can we also, in a contingency situation, keep the capacity terrestrial high in case of a VHF failure? So this is work in progress, where it's basically a proof of concept, which is again also going to be closed in 1 year from now, or 1.5 years from now. This is where the demo will take place, so oceanic area. Navigation, last domain. We're looking here at three elements, I would say, so area navigation and approach and landing, with the distinction of CAT 1 and the CAT 2-3 landings, so low visibility. But also important to keep in mind is accurate airborne time reference. The GNSS in particular is providing a very accurate time reference on board, that in case there is a GNSS failure, which is some of the things that we are looking at in the APNT, for example, is not obvious how to keep things synchronized. So why would we look at the possible vulnerabilities of GNSS? Well, there are two main contributors, I would say. So the first one is frequency jamming. You see in particular that most of it is related to areas where there is military instability, let's say, or geopolitical instability. Some of it is in other regions, which is usually related to just collateral damage, where, for example, professional drivers are jamming the GPS signal in order not to be tracked if they want to have an unauthorized brake, and it by accident happens to cause GNSS failures in an aircraft. The other is solar activity. So the solar flames can lead to ionization in the ionosphere, and that can bend the GNSS signals. So if we want to make sure that we can mitigate the impact of that, there are basically two things to do that, which is use multiple constellations so that we are less dependent on one angle, or let's say the few satellites that you would have available if you only choose one constellation, but also multiple frequencies. So GNSS in each of the satellite constellations uses 2 frequencies. Then what the correction mechanisms, there are actually 2 that are available. So it's either space-based, like the EGNOS and WAAS that Martina already mentioned, which is at the regional level, or you could actually go to a local level and be even more accurate, so at the airport level, and that is what we call GBAS, a ground-based augmentation system. And then if you look at what that means in terms of the translation to the operational accuracy, so the landing categories, we see that with space-based augmentation, we can reach a CAT 1, or can support the CAT 1 operations, CAT 1 landings, which are single constellation, single frequency. There is research ongoing to actually do the SBAS with multi-constellation, multi-frequency, and try to reach CAT 2. And then on the more tailored airport GBAS, so at the local level, we have different versions of that, GAST-C, GAST-D, and GAST-F, with single constellation, single frequency, up to multi-constellation, multi-frequency, where the last one is actually still a bit lower in maturity level due to discussions at ICAO level about the architecture that needs to be chosen there. And then other topics that we will have for future research related to navigation are, well, what I already mentioned, APNT, but also the U-space high altitude operations. And in particular, what is relevant here is that I took this picture from the airspace architecture study. This is where we have our commercial aviation. On top, we see the high altitude operations, and below we see the U-space operations. And here we have barometric altimetry. In the high altitude operations, that actually doesn't work because the gradient of the air pressure is not big enough to actually make a distinction in altitude. So that means in the high altitude operations, you actually need geometric altimetry. If you look at the U-space, the barometric altimetry doesn't really work because most of the drones do not have any barometrics because it takes too much space in a small drone. So they would be using geometric altimetry as well. And that leads to a question like, how do we want to do the interface? Is this maybe a reason for moving from barometric to geometric altimetry? We actually, again, had a webinar on that. You can look back at that. And again, that is just faraway research. Let's say we're hoping to have that research launched in the next program. Surveillance, I would say not much research that we have on space-based surveillance, with the exception that we are looking at integrating also space-based ADSB into improved monitoring by combining surveillance signals, so and improving end-to-end performance monitoring, knowing that space-based ADSB has already been certified by EASA and is actually being used in operations by NAV Canada and NETS since 2019. That was it. I hope I did that in 10 minutes. Back to you, Jackie.
Thank you very much, Ruben. It's a little bit more than 10 minutes, but it was very, very interesting to have an overview of the SESAR activities on the satellite. So I see that the chat is very active. There is a lot of questions, and there is a lot of answers as well that are given by our panel members to the question on the chat. I hope we'll have the time to come a little bit because we are slightly late regarding the presentation. So I will ask the next two speakers to speed a little bit more. Now it's time to have a look outside Europe, and we have the pleasure of having Ravin Jain together with us. Ravin works for the FAA Directorate of Aircraft Certification Service. He is the FAA authorized representative at the RTCA 222 and EuroKA Working Group 82, which is developing standards for SATCOM airborne avionics. So hence very well aware on what's going on SATCOM. He closely works with FAA next-gen roadmaps on the US NAS services. Prior to join FAA 7 years back, he worked for aviation manufacturer as well and cellular service provider. So Ravi, thanks for being with us today. We are listening to you.
Thank you, Jackie. Sorry, I was not sure how are we doing in time, and I was thinking that probably you will wrap up and we'll come back again tomorrow or some other time. But in brief, I won't take too much time. We are already over time. Just so that you know, the FAA as a whole, and then NextGen, which is, you can say is equivalent to Eurocontrol, working with them. We also have a SATCOM future study group involvement. My purpose actually is to just talk in brief about where FAA stands in general when it comes to SATCOM, to help relieve the saturation and the VHF channel capacities. But before I take you to the main slide, which is just one slide, just want to make all of you aware that this whole thing started in 2003 when we had 11th Air Navigation panel getting together. From that time onwards, we formed the ACP. I'm just moving quick here in the benefit of time. And during that 11th Air Navigation panel meetings, a coordination committee was formed, and they studied multiple available technologies at that time. It was very soon realized that European and US bodies have to work together to come out with solutions. It was thought that at that time we will have just one solution which could cover all our needs globally in all different airspaces, but very soon we realized that that is a vision too far. At the time there were multiple solutions offered, and now here we are talking about SATCOM. And sorry for making it go a little faster. Here we are, and all I want to say at this time is that in FAA, we have a domestic, US domestic SATCOM strategy, and we will introduce SATCOM domestically when and if needed to supplement COM data. SATCOM Class B is timed at this time within our strategic plan for FY 2030, and that definitely supports IPS. I think looking at the last bullet point here, we will consider commercially available satellites for our performance-based requirements for mid to far term, which is 2030. There is no plan to have any special purpose SATCOM plan at this time. It's going to be all commercially available satellites. As you will see in the slides, which Jackie will be sharing with all the participants through the means I'm not aware of right now. But once you have that available and through some other means, you will see here where US stands at the bottom. And though definitely in coordination with the Europeans up in the yellow portion and also in the oceanic. But looking on the left-hand side, if you see from the US continental SATCOM B specific focus here, as the applications will be growing, around the time frame when on the European side, there will be SATCOM Class B services. US definitely has a plan to implement IPS by the time frame 2027. Hopefully, by the time we'll have the SATCOM and B2B services available for domestic areas. At the bottommost here, as you'll see, Aeromac is in progress. I will also share the list of all the standards and ICAO level information you have available. But with the Aeromax coming in by 2027, sorry, we hope that a lot of congestions and channel saturations challenges will be taken care of, at least at the surface level. And then at the bottommost right-hand side, you will see that which aligns with 2030 timeframe, that we will have a future potential SATCOM Class A services also being considered at the time. I won't take too much of your time. Just for a quick information, in the slide you will see that the listing of all the standards between ERINC and RTCA and ICAO are available for your consideration, and also some of the other related activities which are kind of working towards IPS standards and security and so on and so forth are also available, so that you can bring all that information together and help achieve the future vision here. With that, Jackie, I will give it back to you. I hope we still have audience waiting for us to wrap up this webinar. Thank you so much.
Thank you very much, Ravi, for being quick. I think, and you said a few important things to me that are consistent with what is going on in Europe, is considering potentially the use of commercial off-the-shelf service. We have seen Ruben talking about, let's say, a commercial off-the-shelf, and ICAO talking about interoperability on the basis of the performance-based operation. So we may come back to that later on, because we have had a few questions. And you mentioned something also important, which is the migration to IPS, which is one of the questions that we have had on the chat as well, on which we will try to answer later on. I suggest that we move on to the last speaker for today, Davide Corinaldesi. Davide Corinaldesi is working for the SDM. He owns the Master of Science of Electronic Engineering at Rome University. After a period in Alenia Marconi system, which is today Leonardo, he joined the ENA, which is the Italian air navigation service provider, assuming several roles in CNS system design, especially on data link, including satellite data link and VDN Mode 2. Since 2016, he's joined the SESAR deployment manager. It was important to have Davide together with us today as a data link implementation project manager, responsible for data link synchronized deployment in Europe, including the recovery plan and deployment. So Davide is also the ICAO panel member in Montreal, and is going to make a presentation today focusing on what is going on in Europe. Davide, if you can do it in 10 minutes, that would be excellent, because then we will have 10 minutes to answer to 2 or 3 important questions. Davide, the floor is yours.
Thank you, Jackie. Thank you for introducing me. I will try to say in the time slot. I'm just sharing the slides. Do you see my screen, just to confirm?
Yes, it's coming. Not yet in the full screen mode, but we can see your screen.
Okay. So first of all, good afternoon, good morning, and evening to all the participants. I'm going to present you the SDM view related to the deployment of the new communication technologies, including the SATCOM. The presentation is organized in 3 main sections. First, there's the overall recommendation for DLS future. Second is the SATCOM in a multi-link environment. And then finally, the final remarks. Going in the first section, starting from 2016, the SDM elaborated the DLS recovery plan that was based on the EASA report, as well as also the ELSA study outcomes. In this DLS recovery plan, we included also a reference to take into account the complementary technologies, including the space-based technologies. Why we considered already the communication technologies at that time? Because the adoption of the complementary technologies seems to be necessary to offload the VDM02 network, also to extend its lifespan, and also to support the introduction of new data link services in the future. Then also because ELSA study recommended to introduce alternative communication means, especially for AOC, giving priority to the airport domain. Then the adoption of the complementary technologies for sure will enhance also the performances, also the flexibility, the scalability of the future data link systems. Taking into account the introduction of these new complementary technologies, we have to consider that we will enter in a so-called multi-link environment because we already have the VDM02, and for sure, if we will introduce other communication technologies, including SATCOM, for sure we will go into a multi-link environment. And then here we have also to pay attention to a smooth transition from the current situation based on VDM02 towards the new configuration. We have to consider that we are touching a system that is already in operation. Having said that, the main outcomes of our work on this, let me say, topic or multi-link environment has been reported in the D11.1.1 report that we have issued in 2020. Of course, the document is available upon request, where it's clearly introduced the pan-European DLS service. And of course, if you would like to introduce the pan-European DLS, and this is the strategy that we are following, we have to give a look to review the management level, the technical level, and also to give a look to the future evolution of this new configuration. Regarding the management level, we have to consider the AC DLS governance, so ATS Common Data Link Service governance, then the unique European Data Link Service Provider, the so-called DSP, and then we have to look at technical level to the new DLS architecture that for sure will consider in the future new technologies and also new data link services. For example, we can mention the ADSC with the EPP services. Of course, together with the DLS strategy, we produce also the roadmap that is associated to this strategy. And here we are glad to report that the first 2 points have been reached. One related to the program management, because we are continuing to work together with European bodies and other relevant organizations to the program management of DLS. And second, the ACDLS governance establishment. Then in this development strategy, you can see also the new DLS architecture that will include the consideration related to the DSP and to the architecture, and also the new technologies like SATCOM and other ground-based technologies like LDAX, Aeromax, and others. Just to mention the governance establishment, the CDLS governance establishment that was established in October 2021. Now our feeling is that this governance will act as a single European entity for taking decisions related to DLS together with the airspace users organization. And we are quite sure that it could speed up and also to simplify the process in order to introduce new communication technologies, including the SATCOM. The second part of this presentation is more focused on the introduction of new communication technologies, the way to deploy new communication technologies, including SATCOM. We would like to follow a simple stepwise approach. First, SDM has elaborated the SESAR deployment plan as usual, and here we are considering also the technological enablers that are needed, for example, for the F6 implementation, and for sure in these technological enablers, we can consider also new communication technologies, including the SATCOM. Second, more specific for SATCOM, the focus should be on short, medium, and long term. And then we have also to give a look to already mentioned the systems like medium Earth orbit and LEO, and also supporting ICNS applications. Finally, when everything will be clear, it will be possible to deploy the data link multi-link environment in a synchronized and harmonized way. That is, at the end, our work to guarantee this deployment. During the work that we have done already in the multi-link on the multi-link environment, for example, when we worked on CONOPS for multi-link together with the use or no use of IDRP, that is more related to the ATN OSI RF layer, we discussed also a lot about the potential transitional scenarios that we could have in front of us. And here you can see a relevant picture that is considering the current situation, the medium-term vision, and then the long-term vision that are based on the information and elements that are today available. It's clear that this picture could change in the future because is under our analysis, and for sure it will be worked on also together with the other stakeholders and experts. What is very relevant in this picture is that we are considering, first of all, not only ATN OSI, but we are considering also ITN IPS. So there is also the transition among the two protocols. And here you can see that in current situation, in the medium situation, in the long term, SATCOM are always present because we consider these technologies relevant because it could cover some of the, let me say, of the requirements that are required by users. Finally, the prerequisite for the deployment phase. We have already identified some general prerequisites that are essential before to move in a large deployment phase. It is clear that we have to reach a technology maturity achievement based also on a deep testing phase in order to prevent IOP issues. Then we need also to consider the maturity of the standards and technical requirements that are very useful in order, again, to speed up the deployment later on and to avoid any kind of problem in terms of technical deployment. Then it is very relevant for us to have the stakeholders buy-in achievement, stakeholders ground and airborne, because here it's very relevant to have, let me say, a common view or a common target in order to speed up the deployment. And these stakeholders buy-in achievement, of course, it will be based also on dedicated CBA or business cases, of course. Then we have the industrialization achievement that is needed, clearly needed. And finally, also the regulatory framework has to be fully defined. In this way, for any kind of new technologies that we would like to introduce, and including also SATCOM, in this way, it would be possible to have a successful deployment. Together with a strong project management, in close coordination among the European bodies, and also involving all interested European DLS stakeholders and not only European stakeholders, because we know that the global approach also will play a relevant role in this deployment. Having said that, SDM is already contributing on the general prerequisite. We are working on that together with the other bodies, entities, and stakeholders. And ready to work, we are ready to work then to pass into the deployment phase. and we are ready also to support European bodies and also the DLS stakeholders. So this is our work, our main work. Finally, the final remarks. It is very, very relevant that we have to take into account the lesson learned, the experience that we already have related to the VDMO2 implementation. We know this implementation was positive and negative at the same time. We had some issues, mainly based in interoperability, and then it resulted in fragmentation. Of course, we have to take into account this lesson learned in order to prevent similar problems also for the future, especially when we will introduce new complementary technologies, including SATCOM. Then one second point related more to the SATCOM deployment is to consider the worldwide nature of the space-based technologies. So a global approach has to be considered, because this type of technology for sure could facilitate to reach a global approach, and it will be possible to reduce at the end problems related to the interoperability, and also optimization in terms of costs would be possible in the future. In this sense, SDM is already working, for example, with FIA together with the Eurocontrol Network Manager, in cooperating with them in order to work on the implementation of the same data link services, protocols, and technologies for the medium and the long term. Finally, once again, I would like to remind you that SDM is already working in the general prerequisites definition, and we are ready to support the deployment of these new communication technologies, including SATCOM, as soon as it will be possible in an efficient way. Just it. So I give you back the floor, Jackie. I would like to thank you all for your attention.
Thank you very much, Davide, and thank you very much for concentrating on the most important topic. We are coming at the end of the presentations. I've seen a lot of questions on the chat. I would like to introduce quickly two members of the panel today. The first one is Antonio Garuti, who is the head of Telecommunication System Project Office at European Space Agency, at ESTEC, and also Hakim Bowman, who is coming from the A4U Airline Associations, A4 Europe, sorry, Airline Association, and he's also co-chairman of the joint CNS stakeholder team. So looking at the different questions, maybe we can start with a question to you, Antonio, because I saw an exchange on the chat on the latency and what should be specified in the latency, and what is most important is to have a guaranteed latency than a very good latency 90% of the case. Maybe you can come back to these questions.
Yeah, well, very in general, of course, Martina in the presentation was defining a standard latency figure for all the various constellation and orbits that were defined as space-to-ground latency. Of course, if the complexity of the system is getting larger and larger, and there is inter-satellite link or whatever other means, the latency will increase, and of course, there will be a situation where the latency of a LEO solution may be higher than the one on a GEO solution. Of course, it is important, as you pointed out, and also as other participants pointed out, it's important to try to have a consistent, stable solution for latency and delays on the system. And while we are doing, I'm talking for IRIS, because IRIS is the project we are dealing with, and not talking for the other solution, of course. But we are achieving results in terms of response of the system end-to-end, not only considering the part associated to the SATCOM, that they are very, very, very important and very in line with the required standardization requirements. So we are very, very happy and very focused on the solution.
Thank you very much, Antonio. We have had a lot of questions on security, so maybe we can ask first to the representative of the airspace users what are very briefly the requirements in terms of security, and maybe later on the technical side, what has been put in place on the satellite system to ensure the security. Maybe we can start with Nopadol or Hakim, and up to you. Nopadol, you can start with security, and then maybe Hakim to explain a little bit what you are expecting in terms of security. And maybe after having the answer from maybe Martina or Antonio on what has been implemented on satellite for security. Maybe Nopadol,
Thank you. Thank you, Jackie. Can you hear me still?
Yes, very well. Go ahead.
Yeah, I mean, that's the cybersecurity aspect is very important, in addition to other things like denial of service and so on. As we know that, some of the new applications that we're looking at, connected aircraft, the integration into the connectivities into the cockpit, connectivities to the flight management system, all of them require to have a robust, but actually, something that work with the cybersecurity that can address the cybersecurity concern. So the need is there for sure. The actual solution is something that we all need to look at. Hopefully it's global, standardized, something that we can count on as part of the standardization process. But also another thing that we need to be mindful about is that, we need to make sure that the space for attack is minimized in some of this communication, because some of the critical system on board the cockpit that eventually would be part of the connections with this. So I think the only thing I would say at this time is that cybersecurity is very important moving forward. It needs to be well standardized. It needs to be hopefully globally harmonized, because the weakest point within the communication chain is actually where the attack would come. So that need to be deployed hopefully at a global level. Thanks.
Okay. Hakim, do you want to complement a little bit?
I take it back.
Yes, I would like to thank you very much for having me on the panel, and congratulations for the event. Quite interesting and very good on detail. Having said that, besides supporting what Nopadol said, we need to make sure that standardized solutions are provided and used, that they are hardened as much as possible. And as he said, a chain is only as strong as the weakest link. But one thing we need to avoid is, or we need to ensure, is that we get a holistic approach on cybersecurity, that we put one security level on top of each other to ensure that the costs and the retrofits are available and not layered in a way that they are not useful, respectively prevent each other from that. So if we have a cybersecurity, especially on these kind of SATCOM links of airwaves, so to speak, then we need to make sure that the endpoint, the starting point, and the transport layer are adequately protected against cyber attacks. But we need to make sure that we don't put too many layers on top of each other, which actually can be achieved with a more efficient way in an appropriate and holistic approach, putting the effort there where it actually makes sense, rather than haphazardly saying everybody has to be safe or secured, and see where it makes sense in the ground, in the air, encryption, in the communication, what is required, but not simply saying you have to do everything in the air and on the ground to prevent horrendous over-specification. That's the point from what I wanted to add. Thank you.
Absolutely, Hakim. Thank you. I totally agree with you. Maybe we can pass the floor quickly to the European Space Agency to explain a little bit what is done in the context of security. And maybe at the end with Vaughan to see whether on standardization they are still ongoing for the security, in order to address the holistic process proposed by Hakim. I don't know, Antonio or Martina, who wants to speak?
Yeah, I will take it very briefly, specifically for IRIS, but in general for future communication system that are dealing with satellite. So specifically with IRIS, as I fully agree with the previous speakers, we don't have to overdo it on one side. On the other side, we have to be compliant with standardization scheme and possibly holistic approach of the future. And in the future, cybersecurity and security in general will grow. Of course, the security level depends on the service we are dealing with. As Martinez presented in our presentation, there are different level of security required for different level of services. For safety services, security, and most of it, availability, reliability, and continuity are essential elements. So we have to keep an end-to-end system, and not only the SATCOM part or whatever part, in a way that is fully guaranteed and achieving the results we want to achieve. Satellite level for IRIS, we used the Swift band of IRIS of Inmarsat that is already kind of certified for secure application, especially at cockpit level. So we are fully compliant. But for future application and future study, we are expanding in many areas. Cybersecurity is intrinsically defined at satellite level if you do not consider jamming. That's why we are dealing a lot with anti-jamming solution for the future, and segregation where needed. So we have all aspects of security involved in the technology development we are dealing with, and especially at satellite level, there will be a need for systems that will be over different bandwidth, over different services, and maybe different constellation. So to be interconnected, will need to be reaching the level of segregation that is necessary depending on the service we want to achieve. But is a very, very large kind of implication, and has to be, as correctly said by previous speakers, understood and required at the right level. Otherwise, the consequence is that the cost and the complexity of the system will exponentially increase. So right level of security for the right service.
Thank you, Antonio. I don't know if you want to complement Vaughan, maybe for the standardization side.
Yeah, sure. Thanks, Jackie. Yes, the ICAO comms panel is working on a number of things at the moment, and they're doing much of this work in cooperation with the Trust Framework Study Group, which is an internal body in ICAO trying to come up with policies for security for not just civil aviation today as we know it, but also for the new entrants, remotely piloted aircraft, non-conventional airspace users, that sort of thing. One of the key things that we're working on is a certificate policy that's appropriate to aviation operations. In other words, not too heavy, but certainly adequate for the perceived threats. That involves a security risk assessment as well. And this will be a readily available document when complete. That is a little different to the security risk assessment already done in the past by the Aviation Security Panel, because theirs was much broader and it covered a lot of aspects, a lot to do with security of personnel, ground side and airside security, whereas we're focusing on the communications part. And again, we're working with the Trust Framework Study Group on that. Other precautions we're applying to use the layered security approach is to obtain an address block that's unique to aviation. And this will be carefully administered. And this will help with such things as intrusion detection and this sort of thing. It'll also have a role in future troubleshooting as well, because we certainly can't have a situation where we're dealing with the Wild West in terms of identifying end users and aircraft. So we need to manage that, and that's being done, again, in cooperation with the Trust Framework Study Group. But as Antonio had mentioned, it really is a balancing act. You can't have too much, but you do have to apply it at all levels. Much of the work being done by the COM panel is focused on the upper layers of the communication stack, because many of the future services like LDACs and the Swift broadband, Iridium service, they already have security measures in place at the link layer. So that's being taken care of, and we don't need to burden them any further, or apply unnecessary requirements to them, because there'll be an extra layer of security higher up, mainly to achieve end-to-end security, which is the ultimate security test, if you will. So I'll stop there. Thanks. Thank you.
Thank you very much, Vaughan. I see that some people are leaving because we are a bit over schedule, with the questions. I just want to recall that we have a coming webinar that will take place soon on the IRIS services, going much more in details of one of these services. So it will be moderated by the European Space Agency. I think there are a lot of questions on the different systems, including IRIS, and that will be the opportunity for you to get the answer to all these questions. Before finishing, I would like to pass the floor to the other panel member to see if they have anything to say. Starting the tour maybe with the other side of the ocean. Ravi, do you have a word to say, or on any other subject, on security, on the, we have had a lot of questions on AOC versus ATM, ATC. I know that in the US, sometimes they are thinking of having a dedicated ATC system. So, I mean, a final word before closing this webinar. We cannot hear you, Ravi, you have to unmute.
Thanks, Jackie. Sorry for that. Yes, I definitely had to say that all this development has to be taken from two different aspects. One is definitely to provide the baseband services, which is the SATCOM constellation connected to these, communication service providers. So security, efficiency. But on the other side, one of our emphasis is to make sure that the airborne equipment, through the process of TSO and ETSO, meets the need. So I think the challenge from the regulatory point is how much we put the emphasis on the box itself, on the aircraft, or on the aircraft architecture as a whole. As I guess Martina covered in detail about from the aircraft control domain to AISD to passenger information systems. So though the SATCOM box is the gateway into the aircraft, and the security starts from there. But also, from the cost and efficiency point of view, we have to look at the bigger picture. So from the aircraft certification and from the SATCOM avionics certification, security is much more beyond, securing the infrastructure itself. And I will stop here. Thank you for asking.
Thank you, Ravi. Martina, you may want to say a final word before we are closing this session?
Yes, very quickly. Thank you, Jackie. So first of all, I would like to take the chance, I haven't done it before, to thank Eurocontrol and also SESAR, the USDM, all the participants to this webinar, and also co-organizers with ESA, to give us the opportunity to talk about SATCOM in this series of webinars. And what I would like to add is indeed stressing also what Ravi said, that we need to have a global picture, looking for what these services need in terms of security, but also looking at what other services which are, of course, less safety critical require, and possibly think of a bigger picture in which we do not think only about SATCOM in terms of costs, but also in terms of flexibility and possibilities offered in terms of multi-service platforms, and also multiple orbits, multi-frequency, or as already I tried to pass messages in the presentation. So I think that's my bit.
Thank you, Martine. Then Davide potentially, and then Ruben. Davide.
Thank you, Jackie. Nothing to add. Just to again to thank you all for the organization of this interesting webinar. For sure, we are looking with interest to the others because the topic, is very, very relevant, considering also the fact that we have to be compliant with both requirements, AOC and ATS that you have mentioned before. I think it is really, really one of the key discussion that we have to do. We have to study in depth, for sure. Again, I would like to thank you all for the organization, for inviting SDM. We are here to support all the stakeholders. And of course, I would like to renew again the thanks for the participants. Thank you.
Thank you, Davide. Ruben?
Thank you. Thank you, everyone, for listening. Thank you, panel members, as well, for excellent presentations. I think it all fits together quite well. Really I was even myself quite enjoying all the presentations. So just some last thoughts. I think for me, the key word is quality of service. So this is where everything comes together, from the glue between the operational needs and the technical capabilities. And I think the next webinar will probably dig in much more into the depth of that. I saw lots of questions on latency and availability. And I think also on the security. I think what I realized there is that actually one of the key contributions to increasing, in particular, resilience is the multi-link capability. And it makes me wonder if maybe that's one for you to discuss as well, Jackie. Maybe we should add one element at some point, or dedicate a webinar specifically to multi-link to explain how everything is going to fit together.
Yep.
Thank you, Ruben. Indeed, there are plenty of questions. So I just want to tell everybody that you will receive soon an invitation for a workshop that we are going to organize on the business case that we are completing now on the future communication infrastructure, that is including the multi-link, where some presentations are planned. This webinar will take place at the end of February. But I would like, now that we are a little bit late, to thank all the panelists first. Thank you for the quality of your presentation, for the presentation that were made that were very, very interesting. We've got a very positive feedback for the audience. Thanks for all those who are listening and who are staying even longer to listen to the question and answer. Thank you very much for your participation. We will try to make all the material available to everyone through website and video when we are going to put a video of the record of this webinar. Thank you so much for your participation, and hoping to see all of you at the next one that will take place on 16th of February, same timing, starting at 3 o'clock Central European time, for having a more in-depth knowledge on the IRIS SATCOM services, which is one of the much mature for operation now, at least in the European airspace. So thank you very much for the colleague from FAA as well for participating. Much appreciated. Hope to see you soon in the panel that will be organized soon by ICAO, together with Nopanol as the chair of the communication panel. So thank you very much, everyone. I'm wishing you a nice day, a nice evening, and hope to see you our next webinar. Goodbye, everyone.
Thank you, everyone.
Goodbye.
Thanks, everyone.
Thanks, everyone.
Thank you, everyone.
Thank you.
Thanks,
Bye.
everyone. Bye-bye.